we're going to talk about testing frameworks, what to think, what to take into account when you want to choose one, and also that makes sense for your team, right? Because we usually work in teams. If you have any other questions related to Sauce Labs, I will try my best to answer them. I might need to circle back with you if I don't know the answer, but feel free to ask anything around automation, Sauce Labs, and of course, the topic we're going to cover today, which is testing frameworks. So let's get started. Before I get deeper into the topic, let me introduce myself. My name is Diego. I have been in Sauce Labs for quite a while, so that's why I feel comfortable answering any questions about Sauce Labs as well. I've been in the test automation industry for about, like around 9 years or so. So I have some experience with testing frameworks, doing testing, different types of testing. So I could also share some insights in if you have any other questions that are not specifically related to Sauce Labs or testing frameworks. I'm currently one of the developers advocates that are here at Sauce, but I'm also one of the leads at the Selenium project. So I'm very passionate about open source, and that's why I think this is a good topic for all of us, because I have learned about several frameworks out there, and I just want to share my several opinions I have about this topic. So what we're gonna do, we're gonna go through some slides I have prepared for you, set up the stage, set up the context for the conversation, and after that, I will just leave the webinar, the session, the office hours for you all to ask questions about hopefully the topic I'm going to share with you. But if you have something else, it's also extremely welcome. So let's talk about testing frameworks. How do we pick one? I have a few things that we should take into account. And the first one is the programming language, right? Most of the time, we only have expertise in one or two languages, maybe three if we're lucky. But it's often, it's not really, we don't think about like, what's our setup, right? I've seen companies that they have the testing role as part of the team. And other companies have the testing role like outside in a different team. Both will work well, I would say. There is no best practice in that sense. I like more when the testing role is inside the team, but a part of the two different setups, I usually recommend that if you are part of the development team and you have the testing role, or the testing role is not a person per se, but it's like a responsibility across the team, my recommendation is usually that the code you write for automated testing uses the same programming language that is being used for the application. So the typical example is a web application written in JavaScript, then you should try to use a testing framework that is also JavaScript. It could be, there are like, I mean, JavaScript has the widest range of frameworks these days. So any of those could be a good fit from the programming language perspective. But if you are not in the same team, if you're in a separate team, my recommendation is to start with a language that is easy to grasp. If you don't have programming expertise, that's what I mean. So the idea here is that if you go out and you check what are the most popular programming languages, then you will find that, yeah, JavaScript is the most popular, and then Python is the second one. So it depends on the survey or the analysis you're checking. Sometimes Python is the first one, JavaScript comes second, and vice versa. In this example, I'm checking the data that GitHub provides us, and it shows that JavaScript is the most popular one, and then Python very close. What I'm trying to say is that we should use a programming language where we could find a lot of resources to get help. And if we're starting, I usually recommend to use Python because it's a programming language that is easy to grasp. It's easy to get something done with a few lines of code. Um, my favorite language is Java, but it's not my first recommendation for test automation because you need to have long code structures to achieve something. So I'm talking about the amount of lines of code you need in Java, maybe in Python you need half of them. And in the end, this helps you with maintainability, code, readability, and so on. So that's a good idea. Think about the programming language before actually choosing the testing framework. One interesting thing when the testing role is part of the team is that if you choose a programming language that is the same one as the team is using for the application under test, you're probably going to get more help from the developers in testing, because if you write tests in, I don't know, let's say C sharp, but the application under test is being developed in JavaScript, probably developers are not going to have the expertise to help you with the automation that you're writing, right? So ideally, if you're on the same page as everyone, there will be more opportunities for collaboration. There's also something else that I like to share often is the considerations we should have regarding test authoring. Why do I mean by that? So of course, there are situations where writing automation is like a solo effort, like just one person is taking care of that. But usually there is a role across the team where people can share the responsibility. And what I'm trying to say here is that when you want to decide what to test, it should be a decision of the team. So the team should be involved and say what makes sense to be tested, what should be avoided. And in general, we should write briefly in a README file or in the comments, I don't know, how the tests are structured and how tests can be executed, can be added if you want to add more tests, and how to remove tests. That's a key thing, because it happens often that, for example, in one of the companies I worked as an automator, test automation engineer, sorry, we had several tests that were testing the UI, the web application, because in that moment it was a monolith. When the architecture team decided to split that into a microservice or several microservices and the UI, we had the opportunity to write API tests for those microservices. But we forgot that several tests that we were writing on the API layer were also doing the same on the UI layer. So we were duplicating the tests that we had. We completely forgot that, and we were running the same test twice. You might think, yeah, but if you're running the test in the UI layer, then you're going to cover everything. That's true, but you may not need maybe 10 tests, maybe just one, and the remaining features, you can test them on the API layer. So what I'm trying to say is that when you are deciding this as a team, there is an opportunity to decide where is the best place to write the test. You don't need to test everything through the browser. And this might sound interesting because, yeah, I'm talking, this is like a Sauce Labs open office hours, but the main message here is that the more browser tests you have, the more complicated the maintenance is. And the more you split them across different layers, it will be easier and faster to run them. And yeah, and together with that, when you make those decisions, if you do pair programming, if you do code reviews, it will be easier to understand what is being tested and how the team can collaborate and see what makes sense to be tested or not. One of the things I like about writing code to do test automation is that you should treat this code as production code. And I have seen this often said in LinkedIn, but not many people actually do that in real life. And one of the best techniques I have found to do that is that the tests should live in the same repository where the application is actually being written. And this is extremely useful because I've done that. I know that when there is a feature being implemented, there is a new branch where the feature is being worked. You can also work in that branch and write the test for that feature while it's being developed. Um, and we have done that. I have done that in previous companies, and it works pretty well because then you can see that the tests that are running on the main branch, they're working well, they're passing or failing depending on the presence or absence of bugs. But for the new feature, you're actually moving at the same pace as the development team. If for some reason they don't release, then you have the test at the same place. But if you had it in a different place, it would be more complicated to find a moment where to merge the test into the main branch. Um, yeah, and as I said, there might be situations where you're splitting your services, so please consider if it makes sense to keep the tests you're having and if they're delivering value or not. So yeah, let's move to the topic of testing frameworks. Now that we cleared the room about like test considerations and authoring considerations. Um, you know, a testing framework is quite a complex thing because many people have different definitions. So there is not a unique thing. Um, this is a list that is not complete. It could be way extended or maybe it's too long for some people. And ideally, we should look for some things that make sense for us in a testing framework. For example, in my opinion, you should have a framework that provides you with a way to assert on the actions you are taking on the test application, right? For example, it should help you to initialize whatever you need to initialize to run the test. Like if you need to create a browser, that browser creation shouldn't be part of the test actually, but somewhere else. And the test framework should help you with that. What else? Like for example, you could have frameworks that are giving you the option to have cross-browser testing out of the box. Um, some testing frameworks would give you the option of expand to mobile when your company decides to release a mobile app or when your company decides that your website should work in a perfect way on a mobile device. So those are features that we should think about before actually choosing the framework, right? Like it's a moment where the team sits together, you think together, and you say, our application is doing this and that, and we need to actually mock the data that we're putting to the application. We need to test this application in different browsers. It would be nice that the people who are using our application have a great experience on mobile, so maybe we should use some emulators and simulators. And if you have a testing framework that provides that to you, then you can focus on actually writing a very good test and not spending hours, days, and weeks building a testing framework that allows you to do that. So this is a list that it's like I leave it there for you all to have a look for like future decisions perhaps. So yeah, like consider it and think about these features that you need before actually choosing the testing framework. And this brings me to the point of, what's the best solution, let's say? Should I actually use an open source framework out there that I see in GitHub and GitLab and in different places? Or should I just take the time and build my own framework? I'm going to make a pause here, like 20 seconds. I would like to see what you think in the comments. I have my opinion already that is very, very biased, of course, but I'm looking forward to see what you think. Please write in the chat something like open source or my own framework so I can perceive what you're thinking about this topic. Okay, it seems that we are not so eager to write things in the chat. Well, thank you, Jennifer, for the opinion. Yeah, it's around that exactly. There's a case for each one of them, but thank you, Alia. Open source. So I have a strong bias to choose open source frameworks. Um, but most of the time they don't work for you out of the box, right? You need to do some tweaking. You may need some plugin. You may need to add a few lines of code to make it work for your case. So it's a mix and match, but I think that the big portion of their solution comes from a ready-to-use open source framework. And the reason for this is that, like building a framework is really, really hard. Like many people think that it's an easy task and they start building their own in their companies. And this has, a really large amount of problems. And when I joined my first, so I was a developer for most of my working life, and then I moved to Germany. And when I joined the first company where I was an automation engineer, we had our own framework. So someone had built something on top of Selenium. And at the beginning, I didn't question this because I was not so familiar with open source, with the automation world. I was just learning, right? But there was a moment where this person left, and there was so much knowledge hidden in that framework that updating it to newer versions, adding new features was extremely complex. We didn't really know. So basically, we had invested a lot of time and money into that internal framework. And when that person left, it was really complicated to move somewhere else. Um, so that is one of the main reasons that if you have something that is open source and you see a good activity in the project, you see good maintenance, you see a good governance, I would choose an open source framework. But with the caveat that Alex is saying, like, you actually need to maybe do a few changes, a few tweaks, so it works for you. So yeah, my primary choice is to do open source and see, um, like find something that works for you maybe 90 to 95% instead of you doing the 100%. And then you add the 5% remaining on your own. But then the topic is, yeah, like how to choose a testing framework, right? Like this is a complex question, because there are so many options out there, and then you don't know really like, okay, where do I go? So what I'm gonna do today, I was gonna prepare basically a step by step on how to move through some questions and then get to a point where you can actually choose a testing framework that works for you. But I found some months ago a blog post that the Google folks posted. So the Google DevTools team posted a few months ago. So I'm going to walk through it, and I'm going to share my impressions. I'm going to share the insights we understand from that, and from there, I hope you also get an idea of what I'm meaning. So I don't know if you have heard of it, but there is a new standard for browser automation coming, that is the WebDriver BiDi protocol. And the DevTools team at Google, they have been working really hard at it. So they took the time to build this knowledge base that basically explains us from like 20, 25 years ago, how test automation has evolved. And what I want to do with you all is to share, um, what this means and my impressions with that. So the first thing they explain is that many years ago, so actually 20 years ago, this year, 2024, is the 20th anniversary of Selenium. That's when Selenium was born. It was created by Jason Huggins, one of the founders of Sauce Labs. And then it evolved to something called Selenium WebDriver. One of the interesting things that when Selenium was created in 2004, what it was doing, it was creating JavaScript code that you were obviously coding, and then it was being sent to the browser and being executed in the browser itself. This had limitations and pros and cons, but it had more limitations than actually benefits. And what is very interesting is that the way Cypress works today is how that first version 20 years ago of Selenium worked. Of course, the UI, the user experience of Cypress is much nicer today, but the concept is the same one. that we had 20 years ago. Then this, like Selenium evolved, and now it's like a standard. It's the WebDriver Classic. That's how we know it today. But then it's evolving to BiDi. But then what happened? Yeah, I forgot. I wanted to ask you this question. If someone like 2 or 3 people can reply, at least, is Selenium WebDriver a test framework? What do you think? No, no. I have 3 no's. Anyone else? Any other taker? Okay, I have 4 no's. Okay, yeah, exactly. Yeah. So Selenium is not a testing framework, and now I'm wearing the hat of the Selenium project, and we have done a terrible job to explain that. Many people think that it is a framework, and we have done a terrible job. And I hope to clear some of those doubts about it in these following slides. But we're not going to only talk about Selenium. We're going to talk about the rest of the frameworks as well. That might be a good option for you as well. So Selenium evolved, and then there is something called the WebDriver ecosystem. So let me explain to you in, I don't know, 20 seconds what this means. We have a specification, so it's like a few files written, like a text written on a few files that says how browsers should be automated. This means when you're doing a click, what the browser should do, when you're typing, and so on. So it's all explained in a specification. Then you come to the point where you have implementations of the specification. Then Selenium is one of them. It's the most popular one. And on top of Selenium, which is to the point that A. Santos is telling us, there are many things built on top of Selenium. So for example, if you think about Selenite, the one on the lower left, it's a Java framework that has automatic waiting. It has screenshots, like there are so many features it has. It has a way to work in desktop and mobile, everything in one single place. For example, the lines of code you need to write for a login test in Selenium, let's say there are, I don't know, 15 lines, including opening browser, closing browser, and if you have page objects, maybe less. But with Selenite, you would need maybe, I don't know, 6, 7 lines, because there is a lot of abstraction that helps you be better and faster. And there are other ones like Selenium Base in Python, you have Appium, you have Nightwatch. So a bunch of things that are out there with so many features that you need for testing. But that's not the only thing. So you have WebDriver IO, which is another implementation of the WebDriver specification. And WebDriver is great because you can do mobile, you can do browsers, you can do all the things about like checking the website performance. There are so many things included there that it's an amazing framework. On top of it, there is something called Serenity.js, and it's a great framework because you can write your test, and then in a configuration file you can say, for this test, use WebDriver. But for this other one, use, I don't know, Playwright or use Cypress. And it's an excellent way to do a mix and match for your testing needs. And then, for example, in the PHP world, which is also a very strong ecosystem for web development, you have things like Laravel, you have Panther. They are frameworks built on top of this huge ecosystem. I mean, the downside is that none of these frameworks are a company, so they don't have marketing, they don't have like a good social media reach, and that's why maybe you don't know them about them so much. But then what happened? Like Selenium was growing, was evolving, and then at some point, the community decided that JavaScript was going to be the programming language that we're going to use to develop the web. And next to that, if you remember a bit, the idea of using the same programming language you use for the application on the test, you should use the same one for testing. Then you have this window, this opportunity of testing frameworks for JavaScript. Then, sorry. Then in 2012, you have like Appium. Then you get to the point of Protractor that unfortunately is now duplicated. The Google team doesn't support that anymore. 2014, you have Nightwatch. Then you have Test Cafe. 2017, you have Cypress. Then Puppeteer is out in 2018. And then in 2020, you have Playwright. Like there is so much happening in the JavaScript ecosystem that there are frameworks coming out almost like every year. These are like the most popular ones, but there are many other ones that are out there. So what's the difference between these frameworks? And that's what I want to explain in the next slide that the folks from Google explain very nicely. So, and this knowledge helps us to decide which framework we want, right? So for example, you have frameworks that are high level and some other ones are low level. For example, the high level frameworks like Cypress and Test Cafe, these ones are tools that execute JavaScript inside the browser. For example, they use these web APIs and Node.js to actually take your automation code and put it inside the browser. And sometimes people think that this makes testing or the automation that you write and execute less flaky. And it's not true, but that's the impression you get because when you put the code inside the browser, the way browsers work, they have an event loop. So there is a loop that collects events, and when the loop gets to the event, then executes that piece of code, right? So the web application is executing normally, and when it gets to the point where it reaches your test that has to be executed, then the web application halts. It's not working in the way a regular user would use it, because a regular user doesn't go and inject JavaScript code into the browser. So when you use Cypress or Test Cafe, that code is being inserted in the browser, stopping the web application to work, and then it unpauses it, and then the application works. So there is it's like a test that is being executed, telling the application, stop, I need to run this, I need to check that, continue, and so on. And I guess you can imagine that there are like so many bugs that could be hidden by race conditions, by, for example, WebSockets that are left open, different ways to like service workers working in different directions. So it's an approach that works very nicely for example, for component testing, because you're just testing a single place of the application that doesn't need to interact with networking, for example. But when you're testing the full deployed application with all the services working, it's a bit risky because it might look that it's more stable, but you're actually stopping the web application from working in the normal way. Now let's talk about the low-level group of tools. And I say tools because Selenium is there and it's not a framework, but WebDriver is a framework. Appium is not a framework, it's also a library, and Nightwatch is a framework. So you have this divided in two. You have the WebDriver Classic protocol, and you have CDP. Please note that under the Playwright logo, you have the modified word. And I'm going to go to that in a moment after talking about what low level means. You know, these are tools that execute commands outside of the browser. So when you do a click, when you do a type, when you do like go to this URL, this is a command that is sent to the browser from outside, and it doesn't interfere with the way the web application is working. And the thing is that when you need more control from the automation script, like for example, you need to open a new tab, you need to simulate a device mode, like you want to see like how responsive the application is, then these tools are great for that because they don't need to execute commands inside the browser. They are executing things from outside as a user would do, right? And then the difference here is that WebDriver is a standard, and that's why many browsers work in the same way. And with the CDP protocol, then you have Puppeteer that is very good automating Chromium browsers. And then you have Playwright that has taken an incredible amount of work of modifying the browsers themselves to make them work properly. So what Playwright is doing is they're using Chromium, which has CDP, and it works for them. So Chrome and Edge should work for them properly. But for example, if you want to use Firefox with Playwright, what they do, they take the Firefox code base, they modify it, they make changes to add CDP to it, and then they give you a binary of Firefox that is modified. It's not the same binary that you would use on the regular laptop. And that's how they achieve the same level of compatibility. Next thing is Safari. I mean, you cannot do that with Safari because Safari is not open source, but what they do, they take WebKit, they modify WebKit, they put CDP on top, and that's how they automate, well, let's say the open version of WebKit that is not Safari. So that's the main difference between CDP and WebDriver, and let's understand that a bit better. So WebDriver Classic, everything is HTTP. So there is a lot of network exchange. So there is a call from your test, and then it goes to the browser, and that's when you have like Chrome driver, Gecko driver, and all these things. And then you have CDP. CDP opens a WebSocket to a direct communication with the browser, and it's always open. So there are messages coming back and forth. And CDP was initially designed to do debugging. And that's why there is so much information flowing from the browser to the automation script and vice versa. And it's pretty good because it's faster. Like you can, for example, say things like, the typical example is in an automation script, you can say, wait for this element to be present, right? With CDP, you can say something like, let me know when that element shows up, and while that happens, I can do something else. And that means that your automation could be faster because you could do, I don't know, like prepare the next data for the next click, or you could like wait for something else while the element is showing up. And that's very useful because that's how the modern web works. There are many things happening at the same time. The downside is that CDP works only with Chromium browsers, and it's not a standard, so it might change. So the test right today could be broken tomorrow, and that's unfortunate. So what's the future of it? The future is that we want to have a way to do CDP in a standardized way. And you might wonder, what is this low-level controls, right? Low-level controls is a way to get more information from the browser. It's not enough to click on an element and know that the application now went to the checkout. That's not enough. You also want to know if the application is showing errors on the console, for example. Then you can go to the console and see all the errors that were placed in the browser console. Maybe you want to avoid the test application to, I don't know, do Google Analytics or go to Facebook ads. Then you can actually intercept those network requests. Maybe you want to test responsiveness and you want to reshape the window, the browser window. And then you can do like the geolocation simulation and much more. So one question that is being asked in the chat is that if this functionality is only available with low-level test. No, because I know that Cypress can do it, and Cypress is a high-level framework. So what they do, they have to combine things. They have to do all their stuff in the browser, and then some of those things have to do it via CDP or via different ways they have to do that. So, but most of their execution code is done in a high-level way, and then they have to plug different other things to actually complete the job, which makes a framework, I mean, it's harder to maintain for them, yeah, but in the end, they're a company. So in some way, they have budget for that. But yeah, that's a very good question because some high-level frameworks can still do something like intercepting network requests. So yeah, this is most of these things is not there are not really possible with WebDriver Classic because there is not a possibility to use WebSockets there, and that's why Selenium 4 included the CDP part. But the next thing is called WebDriver bidirectional, and the idea of it is that all the browser vendors, so you have like Apple, Mozilla, Microsoft, and Google working together to define. I should not say this, but basically the gist of it is like, how can we do something like CDP across all browsers, but it's not really CDP. It's like it's a standardized way of having a low-level control of the browsers. And you might say, but we have CDP and Chrome is the most popular browser. I don't need anything else. And say, yeah, like that might be a good reason in your situation, in your case. But there is a huge amount of people using things like Safari. In the US, for example, there is a good market for that. And then you would like to do the same things you do in Chrome in Safari, and eventually we're going to get that. Oh, CDP is the Chrome DevTools protocol. That is what basically triggered all this conversation about getting a way to have more controls, more low-level controls to understand what is happening inside the browser when you are running your web application. Apologies that I didn't expand the abbreviation. So yeah, the folks from Google are basically telling us that it's a new browser automation protocol that you can use for everything across all browsers. And one of the key things is that Puppeteer was only using Chrome DevTools protocol in the past. And they are now slowly moving Puppeteer to become a cross-browser automation tool by using BiDi. So Puppeteer is now also a great option because you can do Chrome, you can do Firefox, and eventually you will be able to do Safari. So now we can move and expand the ecosystem. Like you could see that I moved things a bit to the left because now here we have Puppeteer as well. Puppeteer is now part of the WebDriver ecosystem. And one of my predictions, and a few more people I know closely, is that eventually Playwright will be there as well, because all this work of patching browsers in every single release, making new features and having to go and change WebKit, change Firefox, and maintain their different services, it's a lot. So we think that eventually we're going to collaborate, we're going to be an ecosystem that works well for everyone. And yeah, I think that's the most that I wanted to share with you all. There is a few non-technical considerations that I want to share when thinking about a testing framework, which is extremely important as well. If you want to choose an open source framework, check the repository, like how active it is, if people reply to issues, if there is a constant way of like new pull requests, and how much activity is happening in the repository. What type of support channels they have. Maybe they have like a Slack channel, maybe they have like GitHub discussions, but in some way you need to understand how you can ask questions to them and how can you get proper replies. I mean, not like enterprise level support, but at least something decent that you get a reply like in 1 or 2 days at least. Documentation is super important, but ideally you should check that the documentation is up to date, that is changing constantly, that you see that new feature came up and there is a documentation connected to it and so on. And yeah, involve the whole team in the decision of choosing a framework. Just don't do it yourself. Don't let your manager do that. Don't let like someone else do that. Like also take your seat at the table and as a team decide what's important for you. And yeah, I think that's the part that many people miss, and it's that we don't do a real proof of concept. We do like the hello world example, but we don't really take our application under test. And we use that framework to test it. Like, for example, if you want to try Cypress, go for it, but then write the test that you actually need to do to test your web application and see if that works for you. And one last thing that I think is very important, check the governance and the community. See how the community interacts with the project. See if it's like only one way, so project to community, or if there is like a nice collaboration, and check the governance. And by governance, I mean how open is the project to receive new contributors? How open is the project to collaborate with other projects? Because what happens these days is that you have two big projects that are Cypress and Playwright, owned by companies, and they are great projects. They are like super nice. They are easy to use. But my concern when a company owns a project is the same one that I had when I knew about Protractor. Protractor, owned by Google, eventually they decided we don't want to do this anymore. They shut down the project, and people had to find ways to merge their not to merge, like to migrate their tests to something else. So writing test automation is an investment for you: time, money, patience, teamwork, and many other things. So try to choose a project that in some way the governance guarantees that it will be long lasting, it won't be owned, it will be continuing, and not any company will come and say, yeah, like this is not going to happen anymore.